Hello, everyone. Welcome to our Deep Dive podcast, where today we'll be reviewing the influential paper, LIMA. Less is more for alignment. Are you ready to explore how just 1,000 examples can align a massive language model?
Absolutely. This paper has been making waves in the AI community. The idea that a 65 billion parameter model can be aligned with so little data is fascinating. Let's start by setting the stage. What's the traditional approach to training large language models?
Traditionally, large language models are trained in two main stages. First, there's unsupervised pre-training on massive amounts of raw text. This helps the model learn general-purpose representations. Then, there's a second stage, large-scale instruction tuning and reinforcement learning, often using millions of examples and human feedback to align the model to user preferences.
Right, and that second stage is usually very resource-intensive. But the LIMA paper challenges this paradigm, doesn't it?
Exactly. The authors of LIMA wanted to measure how much alignment really depends on that second stage. They hypothesized that most of the model's knowledge and capabilities are actually learned during pre-training, and that alignment is more about teaching the model how to interact with users, essentially, learning the right style or format.
That's a bold claim. So, how did they test this hypothesis?
They took a 65 billion parameter LLMA model, which had already been pre-trained, and fine-tuned it using only 1,000 carefully curated prompts and responses. Importantly, they didn't use any reinforcement learning or human preference modeling. Just standard supervised loss.
Only 1,000 examples? That's a tiny fraction compared to the millions used in other models. Where did these examples come from?
Great question. The examples were sourced from a mix of community Q&A forums like Stack Exchange and WikiHow, as well as manually authored prompts and responses by the paper's authors. They also included a small number of safety-related examples and some from the supernatural instructions dataset to increase diversity.
So, the training data was both diverse and high quality. How did they ensure the responses were stylistically aligned?
They focused on making the outputs consistent with the style of a helpful AI assistant. For instance, answers often started with an acknowledgement of the question, followed by a clear, detailed response. This uniformity was key to the alignment process.
That makes sense. Now, let's talk about the results. How did LIMA perform compared to other state-of-the-art models?
The results were remarkable. In a controlled human study, LIMA's responses were rated as equivalent or strictly preferred to GPT-4 in 43% of cases. Against Google's Bard, that number was 58%, and against OpenAI's DaVinci 003, it was 65%. These are models trained with much more data and, in some cases, reinforcement learning from human feedback.
That's impressive. Did they also test LIMA's ability to generalize to unseen tasks?
Yes, they did. LIMA was able to handle complex queries, from planning trip itineraries to speculating about alternate history, even when those tasks weren't present in the training data. In fact, 88% of LIMA's responses met the prompt requirements, and 50% were considered excellent.
It sounds like the model's pre-training really did most of the heavy lifting. What about safety? With so few safety examples, was LIMA able to handle potentially harmful prompts?
The authors tested this by including 30 potentially sensitive prompts in the test set. LIMA responded safely to 80% of them, including 6 out of 10 prompts with malicious intent. However, when the malicious intent was implicit, LIMA was more likely to provide unsafe responses.
That's an important caveat. So, while LIMA is strong, it's not perfect, especially in edge cases. Did the authors perform any ablation studies to understand what factors contributed most to LIMA's performance?
They did. They found that increasing the diversity and quality of the training data had a significant positive effect on alignment, while simply increasing the quantity of data did not. In other words, more diverse and higher quality examples were more valuable than just more examples.
That's a key insight. It suggests that, for alignment, it's not about how much data you have, but how representative and well-crafted it is. Did they also look at multi-turn dialogue capabilities?
Yes, they did. Initially, LIMA was trained only on single-turn interactions, but it was still able to conduct coherent multi-turn dialogues. When they added just 30 handcrafted dialogue chains to the training set, the model's performance in multi-turn conversations improved dramatically.
That's amazing. It really reinforces the idea that pre-training imparts most of the model's capabilities, and alignment is about surfacing those capabilities in the right way. Let's talk a bit about the methodology. How did they evaluate LIMA's outputs?
They used both human annotators and GPT-4 as annotators. For each test prompt, they generated a single response from LIMA and each baseline model, then asked annotators to compare the responses and choose which was better, or if neither was significantly better.
And how consistent were the annotators in their judgments?
Inter-annotator agreement was quite high. Among human annotators, agreement scores ranged from 78% to 82%. Agreement between GPT-4 and humans was also high, around 78% to 79%. This suggests that the evaluation was reliable.
That's good to hear. Now, let's dig into the ablation studies a bit more. What did they find when they varied the diversity, quality, and quantity of training data?
When they compared models trained on diverse Stack Exchange data versus homogeneous WikiHow data, the more diverse data led to significantly higher performance. Similarly, filtering for high-quality responses improved performance by about half a point on a 6-point scale.
And what about scaling up the number of examples?
Surprisingly, increasing the number of training examples from 2,000 to 32,000 did not improve response quality. This suggests that, for alignment, there are diminishing returns to simply adding more data without increasing diversity or quality.
That's a really important finding. It challenges the common assumption that more data is always better. Did they provide any examples of LIMA's outputs?
Yes, the paper includes several examples. For instance, LIMA was able to provide detailed parenting advice, generate recipes, write stand-up comedy skits, and even handle out-of-distribution prompts like ordering pizza online. The responses were generally coherent, informative, and stylistically consistent.
Were there any notable failure cases?
In their manual analysis of 50 random examples, 12% of LIMA's responses failed to meet the prompt requirements. There wasn't a clear pattern to these failures, but they tended to occur in more complex or ambiguous prompts.
That's still a strong success rate, especially given the limited alignment data. What about the limitations of this approach?
The authors note that constructing high-quality, diverse alignment examples is labor-intensive and difficult to scale. Also, LIMA is not as robust as product-grade models. It can sometimes produce weak responses to adversarial or unlucky prompts.
So, while LIMA demonstrates the power of pre-training and the importance of data diversity and quality, there's still work to be done to make these models more robust and safe. Did the authors suggest any future directions?
They suggest that future work could focus on automating the creation of high-quality, diverse alignment data and on developing better methods for evaluating and improving model safety. They also highlight the need for more research into the scaling laws of alignment.
That makes sense. Before we wrap up, let's summarize the key takeaways from the LIMA paper.
Sure. First, almost all of a large language model's knowledge and capabilities are learned during pre-training. Second, only a small amount of high-quality, diverse alignment data is needed to teach the model how to interact with users. Third, increasing data diversity and quality is more important than simply increasing quantity. And finally, even with minimal alignment data, models like LIMA can achieve performance competitive with state-of-the-art models trained with much more data and compute.
That's a powerful message. It suggests that, with the right approach, we can make large language models more accessible and efficient to align, without the massive resource requirements of current methods.
Exactly. It opens up exciting possibilities for the future of AI alignment. Well, that brings us to the end of our review. Any final thoughts?
Just that LIMA is a great example of how rethinking our assumptions can lead to big breakthroughs. I'm excited to see how this work influences the next generation of language models.
Me too. Thanks for joining us today, and we hope you enjoyed this deep dive into LIMA Less is More for alignment. Until next time, keep questioning, keep learning, and stay curious.
Goodbye, everyone.
Goodbye. Randomous it number
To summarize, the LIMA paper demonstrates that with a strong pre-trained language model, only a small, diverse, and high-quality set of alignment examples is needed to achieve competitive performance, highlighting the importance of pre-training and the efficiency of targeted alignment.